Hey guys, this is Miss Fantassel. So today we're going to look at complex fractions. Complex fractions are basically fractions within fractions. So you'll notice I have like a fraction on the top, I have a fraction on the bottom, and then the whole thing itself is a fraction. And so my trick for this is to look for the longest fraction bar, and that's kind of where I start. So my longest fraction bar is here. And so I'm going to rewrite this problem just so that it doesn't look so crazy. So I'm going to put the numerator first. So x plus 2 over 3. Remember that a fraction is just dividing. So instead of writing this like long division bar that's here, I'm just going to write a division symbol. And then divided by x minus 2 over x. Okay, and so now this looks like the other problems that we've done involving dividing, so it's not quite as scary. The first thing that I'm going to do is write my restrictions. So my restrictions, remember, are what would make the denominator equal to 0, because you can't have the denominator of a fraction equal to 0. For this one, there's no variable there, so that fraction is never going to have a denominator of 0, so I don't have to worry about that one. For this one, if x was 0, we'd have a 0 in the denominator, so x cannot equal 0. So that's my restriction. All right, now I'm going to go to the dividing part. So to divide fractions, we keep change flips. So I'm going to keep the first, so x plus 2 over 3. Change to multiply, and flip the second fraction. And so once I flipped that second fraction, and I went over this a lot in the 7.2 video, so if you need to go back and look through that, you can. But once I flip the second fraction, now I have a new denominator. So I need to also write the restriction for that denominator. And so 2 minus 2 would equal 0. And I can't have 0 on the bottom. So I need to include 2 as a restriction for x. Now that I've done that, I just messed myself up. All right, now I'm going to multiply straight across. So this equals x plus 2 times x. I'm just going to put the x in front. And then 3 times x minus 2. You could distribute if you wanted to. I'm perfectly okay with this answer. That is an acceptable answer. But if you did distribute, then it would be x squared plus 2x over 3x minus 6. Either answer is acceptable. For the next example, we're going to do the same thing. So I'm going to take that long fraction bar and just turn it into a division symbol, since they mean the same thing, and then it's just less scary for me. So divided by x plus 1 over x plus 5. I'm going to write my restrictions. So my restriction for this first fraction is that x cannot equal negative 2, because negative 2 plus 2 would be 0, and I can't have a 0 on the bottom. It also can't equal negative 5 because of the second fraction. And so those are my restrictions for now. All right, I'm going to do the next step. So again, dividing fractions, we keep change flip. So we keep the first x plus 1 over x plus 2. Change to multiplication and flip the second. And then our simplifying trick, so I talk about this in 7.1's video and also 7.2's video, but any factor that is in the numerator and in the denominator of either fraction that is the same, you can cross out and replace it with a 1. So x plus 1 and x plus 1 can get crossed out, so that's a 1 and that's a 1. And we're just going to multiply straight across. So 1 times anything is just itself. So x plus 5 over x plus 2 is what I am left with. right, so for this one, same thing. So I have my long division bar. So I have x squared plus 4x plus 3 over x minus 2 divided by 2x plus 6. Now, notice that this is a fraction, but this isn't. And so just to make it a little more user-friendly for me, I'm going to turn this second part into a fraction by putting it over 1, because anything divided by 1 is just itself. Then I'm going to list my restrictions. So my restriction for that first fraction is that x cannot equal 2. And then I don't have a restriction for this second fraction because there's no variable there. So x doesn't affect whether there's a 0 on the bottom of that fraction or not. So we don't have to put a restriction for that second fraction. Now I'm going to keep, change, flip. Change division to multiplication, flip the second fraction. All right, and so in order to see if we can simplify, we're gonna have to factor. And so I do a lot of factoring. We talk about factoring in 7.1, so you can go check that out. I also talk about how to do easy factoring and how to factor out the GCF in 7.2. So if you're having trouble, that's another place that you can look to factor this first expression. So the numerator, there's a 1 in front of x squared, so I can use easy factoring. So I'm looking for two numbers that multiply to give me a positive 3 and add to give me a positive 4. So that's going to be 1 and 3. So x plus 1 and x plus 3. Again, I'm not going to go into that in too much detail because I already did in another video. So go back and you can watch that video. Like I said, 7.2, I talk about it in 7.1. So you can go back and look at those if you're having trouble with the factoring piece of it. I'm also going to factor the bottom of this by pulling out the GCF. So the GCF, remember, is the greatest common factor. It's the greatest thing that goes into 2 and 6, which is 2. And when I pull that out, I'm dividing, so I'm left with an x and a plus 3. And so then I'm going to add to my restrictions. This hasn't changed, but for this one, x cannot equal negative 3. And then I can cross out anything that's in the numerator and the denominator, so x plus 3 and x plus 3 are gone. And then I have x plus 1 left over, and then times 2, or over 2 times x minus 2. This is a perfectly acceptable answer, or you could distribute the 2 on the bottom. Either one of those is acceptable. All right, and that's it for this video. I know I went through this video kind of quickly, mostly because we've already talked about how to divide, we've already talked about how to factor in previous videos. Really, the new piece of this was just changing the way that that complex fraction looks, just to make it easier to work with. So if you're having trouble with dividing or you're having trouble with factoring, please go back and check out those other videos. I hope this helps. Bye.